The mean temperature of the catch index was developed by William Cheng, Greg Watson, and Daniel Pauly in a publication in Nature in 2013, exactly to detect the effects of ocean warming on global fisheries catches, specifically 52 large marine ecosystems around the world. The MTC index, in short, refers to the average temperature preference of exploited fish and invertebrates weighted by their annual catch. Within the catch of a specific region, each of the species can be assigned to a preferred environmental temperature that is considered to be constant through time. Here, for example, for some Mediterranean fishes, we can see how the octopus prefers to be in warmer waters around 21 degrees Celsius, the red mullet a bit colder, and then European anchovy and European hake prefer a temperature around 12 to 13 degrees Celsius, a mean temperature. To calculate the time series of the MTC index, we use this simple formula of fisheries catches and species temperature preference. In the original publication, the MTC index of non-tropical large marine ecosystems that were studied was shown to increase here in red from 1970 to 2010 by 0.23 degrees Celsius per decade, and that increase was in line with an increase in the sea surface temperature that we see here in gray. No evidence was found that fishing or large-scale oceanographic variability systematically altered the MTC. Now, in the 14 tropical large marine ecosystems that were studied, the trends were a bit different. The MTC initially increased rapidly, but then stabilized around 26 degrees Celsius, despite the ongoing increase in the sea surface temperature of these areas, due to the limited scope for further tropicalization of catches in these ecosystems and communities as well. Since its original use on a global scale, the MTC index has been applied at finer regional scales in Europe, Asia, Oceania, and the Americas, resulting in more than 20 publications, with 3 of them being in preparation. The majority of these publications, over 80%, have looked at temperate and subtropical regions, as we can see on this map. Only one will focus in the Barents Sea, that is a polar region, still in the works. Out of these publications, most of them again report an increasing MTC trend, as we see here in the black line and black dots for the Mediterranean Sea. That is again reportedly in line with the increase in sea surface temperature of these regions that we see here in colored bars. The MTC increase in these papers is largely attributed to the increased catches of warm water species that we see here in pink for the Yellow Sea and the East China Sea, while at the same time it's attributed to decreased catches of cold water species that we see here in blue. Only a handful of studies focus on tropical regions, as we can see on the map, and these either report a stable MTC trend like the original publication by Cheng and colleagues, or they report a slightly decreasing MTC trend like here for Indonesia, and that is one due to the limited scope for further tropicalization of catches, as I mentioned earlier, but also due to the expansion of fisheries further offshore and into deeper waters, both because of overexploitation of coastal resources, but also because of climate-driven migrations of marine organisms. Studies have also shown that the MTC can be masked by changes in catch composition that are not related to warming, as in the case of you can see it here, behind here is the Arabian-Persian Gulf, that is a tropical to subtropical ecosystem. Now, in this case, the masked MTC shows a very steep decrease that coincides with the increase in catches of this cold water species, Tehurus lepturus. But this increase in the catches is most likely not driven by warming, but rather it is driven by an increased international market demand from this species, for these species that is supported by export data that you see here in the blue line. So when the authors removed these species from the catch, the unmasked MTC trend that we see here in green appeared to be stable, similarly to other tropical and subtropical regions. Based on preliminary results of a meta-analysis of 11 of these publications that reported specifically a decadal rate of MTC change and span a range of latitudes from 4 degrees in Indonesia to 58 degrees in Lake Peipsi in Estonia, we can see a significant positive relationship between latitude and the decadal rate of MTC change, indicating that higher latitude temperate regions experience faster tropicalization of fisheries catches. Specifically, for every 1 degree increase in latitude, the MTC increases by 0.01 degrees Celsius per decade. Now, if we color code this exact same graph, separating temperate and tropical regions, we can see here that high latitude temporal and subtropical temperate regions have 3 times higher a decadal rate of MTC change compared to low latitude tropical and subtropical tropical regions. The MTC changes are also significantly positively related to the decadal rate of sea surface temperature change, as originally reported and supported by all these new publications, where for every 1 degree change in sea surface temperature, the MTC increases by 1.4 degrees Celsius per decade. This means that the warmer it will keep getting in the future, the more changes fishers will be seeing in their nets and consumers on their dinner tables. An example to illustrate this comes from the Northeast United States and the predatory longfin squid and the northern shrimp Pandalus borealis. We can see in this lower right graph how the green represents the distribution of the usually most southern species, longfin squid, which we can see that in warm years, its expansion, driven by warming waters, its distribution is expanded further north and has a great spatial overlap with the population of a prey species, which is the northern shrimp, and that used to support a very important fishery in the Gulf of Maine that has collapsed. This collapse has been linked to this climate-driven expansion of the distribution of the longfin squid further north. To sum up, the MTC index utilizes widely available fisheries catch data to detect warming effects on fisheries on a global and local scale. Overall, it looks like higher latitude temperate regions experience stronger tropicalization of fisheries catches. And the faster the ocean is warming, the higher the increase in the mean temperature of the catch. Despite the general applicability of the MTC index, observed trends may be more variable and sometimes less predictable at regional scales, since factors unrelated to warming, like we mentioned management regulations or demand-driven targeting, or even the different data sources we use for temperature, are masking the observed MTC trends. To tackle these limitations, we suggest the development of a set of best practices that would address, for example, the species to be included in the index, whether we include rare species or species managed by quotas, whether we use bottom or surface water temperatures to compare. We suggest the inclusion of uncertainty and sensitivity analysis. And finally, we highly recommend the use of survey data to whenever these are available, obviously, to validate the catch-based MTC trends. Since right now only about 1/3 of the papers use survey data, which again makes sense because these are much less available than catch data. With that, I would like to thank you very much.